This gives you the opportunity to really put these in any location that you want indoor. If people bump into it, you're not going to have issues. If a fan gets wild and there's a drink or something that spills on the display, you're not going to have a catastrophic failure.
Hello and welcome to the Daktronics Experience Podcast. We're in-house today to do a live video podcast, live for us anyway. We're here with Matt Anderson, of course, and Adam Gilliland. Adam, can you tell us a little bit about your position and what you do here at Daktronics?
Yeah, absolutely. Thanks, guys. It's my first time on the pod, so I'm excited to be here. I'm a product manager here at Daktronics. I started at Daktronics in 2008, got into project engineering, helping out a lot of different markets. Then got into product management about 10 years ago already. And I help oversee our narrow pixel pitch product line. So this is the very tight, high-resolution rectangles on the wall. We're starting to do some more creative things with doing corners and curves. And we're investing a lot, and we're bringing on some new LED technology that I'm sure we're going to talk a little bit about today.
Yeah, and kind of before Daktronics, were you always kind of a tech person, or like what did you major in? Kind of how did you get into this?
Yeah, you bet. Well, I got an engineering degree from School of Mines, so one of the few here at Daktronics that didn't go to South Dakota State.
Right here too, Northern. So yeah.
I guess
not many of us.
I'm the single one out on that one, then I guess.
And then after college, I got into the construction and architecture industry. And I lived down south in Texas and then had the opportunity to come back here to South Dakota, God's country. And I took that opportunity. And it's been an amazing 16 years. It's gone by in a blink of the eye. And really excited about where the company's going in the future.
Yeah, 16 years and 17 years over here for Matt.
Yep, 17, yep.
Goes pretty fast. So you did mention something in your intro there. You said NPP. Can you tell us what that specifically means when we say NPP at Daktronics?
Yeah, you bet. So that stands for narrow pixel pitch. Daktronics, all our models and series, we use nomenclature, acronyms. So when we talk about NPP out there in the industry, we're talking about indoor direct view LED display products that are less than about 2.5 millimeter in pixel pitch. And what that means from the viewing experience, these are going to be these closer viewing type situations, like less than 20 feet generally. And we have a variety of different pixel pitches, a variety of different product series, all kind of tailored for specific applications and markets as well.
And we're talking about pixel pitches. It's the space between right from the center of one pixel to the next.
Yep, you got it.
Yep,
Yes.
and so when talking about like narrow pixel pitches, some of the examples of like what people might see in a basketball arena. Or what we're down to like 3.9s, 4s now.
3.9s
they keep going
ones.
closer and closer, but it was just kind of like a frame of mind of you don't normally see a narrow pixel pitch in the larger scales, but we're starting to kind of see that line blurred between when does it become narrow pixel pitch or a normal LED display, right?
Yeah, we are, and everything's trending to higher resolution. We're even starting to hear about 8K TVs out there that you can purchase. So it wasn't too long ago we were like, oh, I just got a 1080p TV, and then now all you can buy is 4K TVs. So, and our industry is certainly trending that way. What is very intriguing when you think about, let's just take a 2.5 millimeter pixel pitch. If you jump down to about a 1.9 millimeter pixel pitch, you almost double the amount of the pixels in that same square area. So it doesn't make sense like when you say it, but
it doesn't seem like it's that much of a deal, big of a deal. But
so like the sporting applications, the big huge displays, they're certainly trying to position things around achieving 4K resolution and even larger. So they can do so many unique things with that canvas of that scale.
Yeah, and you're talking pixel pitch, and a lot of these narrow pixel pitch displays, are pixels the same as an LED, or is it different number of LEDs per pixel? I mean, there's kind of different types of LED that we talk about when we talk about that, right?
Yeah, there is. The LED technology is definitely evolving and advancing. So typically with indoor, we use what's called an SMD, a surface mount diode. So that would be an individual packaged pixel that includes the red, green, and blue. And then that's placed onto the PCB. They're very, very small SMDs, about 1 millimeter by 1 millimeter. And we space those at whatever distance to get the center-to-center pixel pitch. And then as we've been getting to these tighter pixel pitches, these products have become quite delicate. We have a few samples here. This is an SMD. You see how small the individual's pixels are.
Yeah.
So with that, one advancement has been the grouping of those pixels into an integrated matrix device. And so that would be 4 of these SMDs kind of grouped into one structure. And we've seen a lot of really good success as if we've deployed this to areas where patrons are very close to the display and interacting with the display. And with that, we've been working on a next generation technology that we call chip on board that is even more advanced in terms of the performance enhancements that it can offer and really the durability or the protection of it. And these are smaller mini LEDs, and they get a layer of encapsulation or molding over the entire tile or lighting element. And this gives you the opportunity to really put these in any location that you want indoor. If people bump into it, you're not going to have issues. If a fan gets wild and there's a drink or something that spills on the display, you're not going to have a catastrophic failure.
Okay.
So this is an example of our new Flip-Chip COB technology, and you can.
Oh wow.
You can
you really tap on that thing.
Yeah, I remember in the old days, but
The
back
old
when I
days,
was an
yeah.
intern, it was always trying to make sure people at trade shows didn't go up and mess with the display. I think it was a 3 mil was the tightest we had at the time, and that was only for a little bit. But
do not touch. Do not touch.
yeah, exactly.
Don't want them to scrape the face of it and maybe damage an LED or something. I wanted to go back just a little bit. You said IMD, integrated matrix device, and you said that was 4 little things put together. So when you talk about those 4 grouped together, is that a pixel itself, or is each of those a pixel, and does that play into the spacing? Just to
It's
clarify.
like Inception. Yeah.
Yeah, each of those would be a pixel. Then that would be the packaged part that our machines take and place onto the PCB. Then they do that many thousands of times over.
Okay, so that's similar to an SMD is that grouping of red, green, and blue in one, and that's the 1 pixel placed, versus the IMD is those 4 grouped together really tight as 1 pixel.
Yep.
Okay, just making sure we clarify
Good
when
work,
we
Justin.
talk with pixel pitch there. We
Yeah.
want to know we're not saying distance between each of those 4. It's those 4 packaged together as one.
Correct.
Yeah, absolutely. And so then going to, we said flip chip or chip on board, kind of what are these terms? And I think that's what we were just talking about.
Yep,
Right?
yep. That's the new technology that we've
Okay.
been working on. Our journey with that, we got into narrow pixel pitch. Our history, even before 2010, we had a 2.5 or a 2.9 that we were taking around trade shows. And people are like, "This is awesome! I need to get this in my house. I need this." And then they would ask for what the price was, and we were like, "Well, it's up there." And they're like, "Ooh, okay." So we were maybe a little early to the game with our journey into NPP. And then as the market evolved, we got back in around 2015 or so. And then with that, we certainly knew about new technologies that were emerging with the Flip-Chip COB. So we've been on the COB journey essentially simultaneously since we've got into NPP. And now here in 2024, this is the time where the performance, the reliability, the commercial price of it have gotten to the point where it's going to be able to really compete and be a really nice offering in our NPP portfolio.
So just to clarify the timeline, you said we got back into it in 2015. Kind of when did we kind of start then? You said we were starting before that and we're a little early.
Yeah, it was about 2007, 2008.
Okay.
That's when we had that sub 3 millimeter product.
So I think I remember it was just one unit
Yeah.
where some of our demo displays would go in different sections, but I always remember it was the one, not 2.9 or 3. We just always rounded up to 3 at the time, but I remember it going to trade shows.
So
The most common question at those trade shows is, like you said, how much does it cost to put this in my basement? Like,
Yeah.
So the better part of 15 years, this idea has been around and we've been kind of refining it over the years until where we're at today.
Yeah, absolutely. And we've seen that in a lot of different markets. They've trended towards tighter and tighter pixel pitches, better image quality. And then we think about indoor in our device-driven world. I mean, everybody expects it to look like your device of your choice that you carry around with your phone or your iPad or your computer.
Or they compare it to the at-home TV.
Yeah.
like this.
Yep.
Right.
And I'm even thinking, I would say we've waited a while, but we've been monitoring it and everything. So is it, from your perspective, what does that look like on your end? Is it, you're always checking in with different suppliers, seeing what's new coming out, we bring it here, we test it, kind of, how does that work?
Yeah, you bet. Well, you guys know we put a lot of effort and investment into R&D. We do something around 4 or 5% of our revenue into that. So we have teams that are focused on developing light emitting LED technology, display technology. That's what our business is. We produce the best displays out there. So we're fortunate to have a team and be able to do that R&D and really just be on the cutting edge of what's happening out there in the industry and the supply chain and the manufacturing processes related with that. Then a big thing goes along with that is the reliability testing. We have a lot of experience with different types of encapsulants and moldings. If we take a look at our journey on outdoor, as the pixel pitches got tighter and tighter, the reliability wasn't there. So we had to do some molding and encapsulation around our outdoor 10 millimeter SMD product years ago. And so we learned so much about that, and we've been able to apply that to the techniques and the requirements and the materials that we're using in protecting the Flip-Chip COB technology.
And a lot of that researching and testing and reliability lab and lab services happens in Brookings, South Dakota, and in the United States. We do a lot of that development and testing right here. So we're playing with the components themselves and able to have our engineers see firsthand what's going on as they're testing and improving the product, right?
Yeah, absolutely. And we know that seeing is believing. So it's one thing to be able to design something or be able to know that it's possible, but you got to be able to see it, We got to be able to produce it and manufacture it. And then we think about the opportunities that we get in the projects that we're involved in. It's just not going to be a 85-inch TV on a wall. There's a concourse that could convert their entire hundreds and hundreds of thousands of square feet into LED.
And they have.
Yeah.
Like Climate Pledge Arena, just that entire atrium is covered in LED.
Yeah.
Yep. Or where the Phoenix Suns play, there's the big one in the concourse
the big
there
entry
too.
displays.
Yeah. So, and kind of just thinking about, this is the markets. We're talking a lot about sports and stuff right now, but MPP chip on board, maybe just speak a little bit about that. Now we're in, I know we work with AV integrators, but now we're in markets that we really have never really been in before because we have this technology, right?
Yeah, absolutely. So our NPP product is really first focused on the pro AV market. So we have an entire team that's set up to help AV integrators out there provide them products and allow them to be successful in deploying to all their different markets. So we have a growing team with that, and we've seen a lot of good success. And we have a lot of really shout out to all our partners out there. We have a growing team of AV integrators and partners that are getting us into new applications and new markets, which is really exciting. It's just not sports. It's just not lobbies. It's just not retail. We're doing stuff with the U.S. federal government. We're getting into some very unique applications in control rooms and operation centers. And you think about the future and the virtual reality and the XR type environments and where things could go with simulation and modeling and the display technologies that will be required for that. We're developing the technology that will be able to be successful in those applications.
Even e-gaming.
Oh, yeah.
I keep hearing those ones keep coming up.
I got to get up. I got to get back into gaming. You know,
There you go.
Yeah, I tried playing my son in Smash Bros. It's not as easy as I remember it was. He kicks my butt all the time. But
I have to go back to like Madden, whatever.
Yeah, there you go. And even talking about these applications, and you're talking more about this chip on board and how we've refined that for these applications. What are some of the things that we're hearing from the industry that's important with this new technology?
Yeah, you bet. So the great thing about having the access to all these partners is we're able to get all this feedback. And we challenge our partners is like, tell us what's going well, tell us what's not working, and we'll bring that back to the drawing board and see how we can help you out, because we want to make your lives easier. We want these installs, the commissioning, the fire amp, all that to be as seamless as possible, because that's going to allow the end user to have a better experience, and they're going to tell their friends like, hey, check out my new DirectView LED Flip-Chip chip on board solution I got from Daktronics. You need to get one. So that's kind of our mindset there. We're in about our fourth or fifth generation of narrow pixel pitch product, and every time we've made some incremental improvements. it's gotten a little thinner, a little lighter, a little easier to install. But with the Flip-Chip COB, one of the huge drivers of how it can be disruptive is the power savings. Okay. So the power is about 35 to 45% less than the SMD and IMD.
Wow.
So when we have that power savings, we're then able to slim up all the electronics, slim up all of the cabinets. And our mechanical team has done a really great job. They set out an ambitious goal. It's like, let's develop one of the thinnest products out there on the market. And we've done that with our Flip-Chip COB series. And the cabinet is less than an inch deep. And it's like, when we first got started on this, our cabinets were like, 3 or 4 inches deep. So they were quite heavy. And I actually brought a sample with here. In our previous generations, I wouldn't be able to pick that up. I would need to get out of my chair. Yeah. But you see how thin this is. I mean, this is it doesn't have the module on the front of it, but it's less than an inch. You could put your phone up to it, and it's rivaling that. And we could even pass this around the table.
Oh yeah, that's not that heavy. I expected it to be heavier. I was bracing to not drop it, but yeah, it's pretty good. You want to hear that?
Sure.
Grab that, Matt.
Oh
yeah.
Wow. Yeah, the intern days, again, back 16, 17 years ago, I think it was a pro tour type stuff and that. We needed scaffolding and everything just to be able to carry that stuff up. But
that stuff had to be rugged. It was set up and torn down show after show, right? This is a little bit different. But even with the thinness of this, is that something that opens up new applications for it? I mean, we've talked about like boardrooms and lobbies and things like that. Is there like, oh, now we can slide this front of a desk or something? Is there new applications just because of how thin it is?
For how this would get integrated into architecture out there, just use architecture as a broad term, it makes it so much easier. You know, if you're talking about a hotel lobby and maybe they want to put this at the concierge desk, you can integrate that right into that without a lot of issues. And even looking ahead with where things are trending, if we look at getting into street furniture or replacing outdoor LCDs, having a thin depth like this can really allow a great base to be able to have this technology eventually get into some of those new applications.
Maybe they're not new applications. It just makes it easier for some of the existing applications. Or
Yep.
Or to try and keep up, like you're saying, with the race to 4K, 8K, and everything else going on.
Yeah, absolutely.
The smaller amount of space needed, right, to get to that resolution, the better. But
yeah, and it's just like the TVs at our houses. Back in the day, you would have this big articulating arm, and you'd have this bulky TV that would be sitting off it. You want it to look sleek and elegant.
Yeah, those old TVs were like 2 feet off the wall, and now we're hanging them on walls.
You need a buddy to help you pick it up and move it,
or 2 or 3.
Yeah, absolutely. And then certainly in these applications with this close viewing, we have the ADA compliancy requirements here in the United States, and there's other international requirements. So American Disabilities Act. So you need a thin depth display so it doesn't protrude off that 4-inch. Distance. So having a very thin depth product allows it to be versatile and be mounted really in any form or fashion.
And we're talking about, we were mentioning pixel pitches, how we have come down. So I'm going to think about how to say this, Justin. Okay. So where does narrow pixel pitch stop on that, and then like COB begin? Like, is it a certain number you get to and then it switches over? How does that line up?
Yeah, you bet. So COB, we're bringing online a 0.9 millimeter, so that's below. So in a very small amount of space, you can get 4K. It would be about 6.5 feet. So height. So that's a very tight pixel pitch. We also have a 1.2, a 1.5, and a 1.8 millimeter. So where the bottom of that is how tight can it get? With the COB technology and not having that packaged element, it's going to be able to get tighter and tighter, go down to 0.7 millimeter, 0.6 millimeter, and then you're on the cusp of where some of the larger LCDs begin to.
That was kind of my next question. Is then when does that start rivaling? Not saying we're going to be in Best Buys anytime soon, but like when do you start saying go with this versus like a traditional LCD or LED TV? Yeah,
absolutely. We are also working on a next generation beyond Flip-Chip's COB that would be called micro LED. And that's where the LEDs are even smaller. We're talking about less than 100 microns, and that's like less than the thickness of a human hair. So that's probably positioned more towards the back half of the decade, maybe a couple years out until that takes over. But that true micro LED is something that will likely disrupt LCD type technologies out there. Then the COB is going to be around for quite a while. And then certainly the other LED technologies, SMD, above 2 millimeter, above 2.5 millimeter, that is the prime LED technology. How that tie that back to Daktronics, it's like we have all these technologies, we test these technologies, we know about these technologies, and we ensure that in our displays that we have the best available LED technology to offer the market out there.
So which pitch would this one be then that we have?
This one would be a 0.9 millimeter.
That's a 0.9.
Yeah.
Yep. So do you want to count
on it.
every single pixel?
Yeah, tape measure.
Yeah.
Well, yeah, with the covering on it, when we were touching it, you could rub your hand over it, and you can't even feel the LEDs. It just feels like a flat tabletop almost.
Yeah, it does. And there's been so much work into the optical performance because we are putting this layer of encapsulation over. So it has to produce a pure image. It can't distort that in any form or fashion. And then from the reliability standpoint, we've all had protective casings on our phone that peel or crack and do all that, whatever. Yeah. You think about the indoor environments and people are like, well, it doesn't really matter. But with what we know, there's a lot of thermal changes that do happen with various rooms. As you turn the displays on and off, there's that thermal cycling. So in the reliability testing, we're testing everything for the thermal expansion to make sure all the components are cohesive and work together and don't fight against each other and cause failures. So it is so simplistic and the result is great, but there's so much work that went into it.
To get to this point.
Yeah.
You were talking about the different factors. You think, oh, it's indoor, it's safe. But I remember back in the day, Matt, there was always the thought of, oh, we're putting an indoor display in an aquatics area. It's like there's a lot of humidity in the air in that area, so they're almost bringing in outdoor safe products into that indoor environment just to make sure that it's safe and operational. That sounds similar here. Is there's different humidity levels and thermal levels when you turn on and off that display in a smaller room or even a smaller space, because it can be in a smaller space, right?
Yeah, absolutely. And these smaller components are so much more sensitive to those temperature changes, to the humidity. And even if people are going to be purchasing a large amount of it, in transit, you have to think about, all right, this is getting on a truck or on a plane, and the different temperatures that it will experience. We've had some customers in the past, in our early days of the NPP, that they would store this in a warehouse or maybe even outside. And then, so we learned a lot of lessons on how can we enhance our packaging. It's not an exciting thing, but you buy the latest smartphone and everyone's like, whoa, they have some cool packaging that you got here. So that's kind of carry over to what we do. Yeah. We provide vacuum packaged modules. So in event that this is going to sit in a warehouse for a period of time before the project's ready, you know that your product's going to be able to be installed and fired up and not have those infantile failures that can really be disruptive.
Yeah, I was going to say, I understand that transport and safety during transport's a real thing. I had an issue with a TV that I bought, and I had to have the third one delivered before I finally got one that wasn't broken. So transport and delivery is important. You want to make sure it gets there safe and then gets installed safely, and you're protecting the product from all of that.
Yeah. So even thinking of, the different narrow pixel pitch we're coming down to, but I don't know if we do have some slides. You did make a slideshow, so we can kind of jump around on that. I don't know if there's anything you want to touch on as far as, what physically is different from, I know we've talked about SMD, IMD, Flip-Chip, all that kind of stuff, but
Sure.
I do have the PowerPoint if you want me to pull it up yet, if you're ready to talk about it, or I'm not sure.
Yeah, maybe we can pull up that visual of the Flip-Chip versus the SMD, this video right here.
Yeah.
Because not often do you get to see at the micro level, like what's really going on here. And this is a really good representation that our lab services group put together. So
there's the human hair over there for comparison's sake.
We're all getting older. It's turning gray. On the left, we have the LED technology that would serve the SMD or the IMD. And you see the metal which is called a wire bond, and that's essentially how the power is being delivered to those light emitters. So I mentioned that the Flip-Chip COB is much more efficient. Well, on the SMD, so power has to go through that metal to get to the LED from the conductive surface. And then you have each red, green, and blue that have those wire bonds on top of it. So in a lot of our reliability testing, this has always been a thing where we've seen failures, we've seen variances, so we have to continue to monitor and watch that. And then when we talk about the Flip-Chip COB, it's a new manufacturing technique. And you look at the right, that wire bond's not there. So
Yeah.
it's directly connected to the conductive substrate. So that's where all the power efficiency starts from. And then that also leads to much greater reliability throughout the lifetime, which is very important to our customers and to the markets. We want to be able to ship them the product, have them have an excellent lifetime throughout their use of the display, and wanting to hopefully call us back in the future to purchase our micro LED or our next generation technology. As, technology changes pretty fast. I can't imagine that people are going to want to hold on to their current indoor technology for decades like we've seen in the past. But we had an experience at one of the Senate houses recently. They had a 14-year-old indoor display product that they were still.
Oh, wow.
They were asking if they could get spare modules for, which is, I mean, it just worked great, and it was meeting their needs. But certainly, as we look at NPP, it's more that emerging technology, people that are really looking to create captivating spaces, or they need that intense resolution to be able to watch what's going on out across the world. So.
Yeah, so that NPP term covers the SMD, IMD, and Flip-Chip or COB product. It's all of those very, very tight pixel pitches. And for those that are just listening and can't see the slides here, we're looking at a human hair that's like the thickness of one of the Flip-Chip lights that makes up the full pixel. So it's very, very thin stuff we're talking about here.
I'm glad you said micron, because it was one of those. I should know what that the two letters there after the numbers were, but I had no idea until you said that. So I was like, okay, so that's 90 microns thick is a human hair.
Yep.
There's 90, and then 96 is the width of one of these LEDs. So
Yeah.
Did you know that was
No, not until he said it.
Yeah, okay. I was just making sure I was.
That's why we have the expert here to tell us what we're looking at. Yeah.
So I know a lot of people then listening, right? You know, we have had some architects or different people in the industry listen to the podcast for technical info. So, you know, when we start saying this chip on board, I'm not sure if it's maybe a summarization, but it's okay, why should I care about this? And then when should I consider using this versus, you know, a face-up chip?
Sure. So the why would be if you're going to be deploying the technology in a space where people are going to be interacting with the display or close to the display, you certainly want to look towards a COB, a protected surface. It's cleanable. You can touch it. There's a lot of trends with interactivity. We've deployed some infrared touch displays with our IMD technology, which is more robust than the SMD, but the COB is even more protected or durable than the IMD. For when this will be available, in the U.S., we're launching 2 series with our Flip-Chip COB at Infocom this year. So that's the big U.S. trade show for our industry that's coming up in June already.
Nice.
And we're going to have 4 different pixel pitches available. We're going to have elevated brightness levels because, you know, many times people want to put this in a very high bright environment. So those elevated brightness levels around 1,000 nits are very helpful. In most indoor settings, you can be around 600 nits. So as we look ahead out to about a year or so, I would see we're going to see a evolution to a lot of our NPP portfolio going to the Flip-Chip COB technology. Now the other products will still be available, and they're still a good fit. They do have some advantages in terms of even some higher brightness levels.
Okay.
But I would say, in general, as we look ahead into the future, the Flip-Chip COB technology is going to be one that starts to take a lead position.
Okay.
Yeah, it's we're trying to bring out multiple technologies to fit all those different applications and a customer's needs. Say that customer wants something specific, we can say this fits perfect, or you should really look at this Flip-Chip COB. Just curious, you said June Infocom. That's when we're showing it to our American audience. Has this been shown anywhere else already yet?
Yeah, we released it at ISE, Integrated Systems Europe. We showcased our 0.9 millimeter and 4K and the COB technology. And we have installed at least a half a dozen, maybe up to a dozen now, projects across the globe. We're making some sales here in the U.S. of the COB technology. So Infocom is going to be our big showcase to the U.S. market. Sure. We're going to have some products there in different pixel pitches, and we have a couple new things that I won't get into today, but maybe put a tease out there.
Okay.
Please stop by our booth at Infocom.
There you go.
We're pushing the bounds of really what's possible in a couple cool performance areas.
Yeah, because it kind of ties full circle back to you saying at the beginning when you start talking about narrow pixel pitch displays that the only way to truly understand maybe the differences of them is to actually see it in person. I know we've had that discussion many times in the podcast with customers is, yeah, LED is great, but then when they actually see a demo of it or something in person, way better than any picture we could show or, no offense, Dylan, any video we could show of it too, but actually getting to see it in person helps out a lot with that. So when you debuted it even at ISE this last year, what was the feedback kind of from the attendees at the show when they saw it? Was it kind of okay, this is definitely something new for you guys? Yeah,
people. So we were showcasing a 0.9 millimeter in our IMD, a 0.9 millimeter in our Flip-Chip COB.
So you can have the same millimeter pitches between the two different styles, even.
Yep.
Okay.
So we had three different displays up there. Then we also had a 0.7 millimeter in the IMD. I remember not too long ago we used to go to trade shows and we were showing like 4 millimeter or the 2.9. So we've advanced a lot real quickly. But what was interesting is that we had the opportunity to, from a distance, you could see all these technologies. They're like, wow, these all look really good. And then you get into talking with the customers and being able to describe the differences between them. And then how it worked at the trade show is that we'd walk up closer to the display, and then you could start to see the slight differences.
Yep.
And then we'd allow people to touch and feel. And that was probably the biggest takeaway by the end of that trade show. I mean, we just had people that were just going up and they're like,
they love to be able to do that.
Just go hit that display. I feel how cool to the touch is, because the Flip-Chip COB has 35 to 40% less power. So that translates into the heat.
Okay.
So
energy savings.
It falls in line with our Cool Runnings design mantra. One of the greatest movies ever.
Remember that had John Candy in it. But so you're saying like the people came and actually could see the difference, they could touch it, they could feel it. Like we were able to actually hold those today. So if you're listening or watching and you're interested in this and you actually want to see that difference or feel that difference, you should probably head on over to Infocom and swing by our booth.
Yeah. And where's it at again? It's in Vegas this year, right?
It's in Vegas, so it'll be about 115 degrees.
There you go. No, I got to imagine anyone that's gone to shows before is so used to not being able to touch the screen. So when you actually tell them they can, it's probably that hesitation. But it's kind of making me think of these different things, because you remember we used to have some demo type displays where we used to sit.
Yeah.
This is probably 12 years ago or more.
Yep.
But how was maybe the sound on them at all? Do you hear any humming going on during these? I think they were like demo displays, like actual demo displays. But
right.
I remember when we turned it on, it would hum. But it was one of those, but they needed fans on it and things like that. So how are these in regards to, like, if it's a quiet room, do you hear it really loud, or how's the noise?
Yeah. Our thermal designs back 12 years ago, with the technology that was available, we did have to put small fans internal to the cabinet to get the air circulating so we didn't build up any hot spots. That technology at the time ran a little hotter. I mean, that was just the nature of it. With this is a completely silent, completely fan-free technology. As you saw in the cabinet, there would be no room for a fan in there.
That's the other part. I was like, there can't be a fan there.
And we're using robust, tested, proven power supplies that don't make any noise. The technology has good performance with EMI, so it's not going to It's not going to interrupt any critical signals or
Sure.
mess with your Wi-Fi or anything
Especially if
like
it's in those boardroom type applications, like you're saying, or even federal government things. I
yeah,
guess.
Oh, yeah.
absolutely.
I suppose
Yeah.
that's a little bit more important than some board meetings, but yeah, that's what I was thinking. Like the audio part of it lends itself to more applications too, because if you're in a conference room presenting, you don't want to have to worry about, is this picking up the sound, or if someone's conferencing in, hearing the sound and stuff like that. But
This is a good tie back to we started working on NPP type products more than 15 years ago, and it's just advance, test, R&D, like you said, about $5 million every year into R&D for the company to try and improve products and services. So think of that 15 years of progress that's led us to this lightweight, thin design that you can tap on even and it won't break.
yep.
That's right.
Yeah.
It-
So is there anything at all about COB that we haven't touched on today, maybe that you wanted to call out or talk about, or?
I think that was a great introduction to it.
Okay.
I definitely invite people to reach out to us to learn more. We got a ton of collateral, and we're happy to share the story.
Yeah, I know we're going to be starting up a little social media campaign here in the
Yeah.
next coming month or so to help push, and it's a lot of educating the market. Like, well, I'm already learning a lot. You're educating us
Yeah.
today, but then we're going to turn around and try to educate others as well. So
Right.
it's a lot of just terms and getting to know kind of what the different terms and acronyms mean.
Yeah, so this has been a good base discussion on all of it, and I'm sure you'd be happy to go in depth with the customer if they were interested in talking even more about it, right?
Yeah, absolutely.
And of course, stop on by Infocom.
And you're going to be
We'll
at
there.
Infocom.
I will be.
Okay.
Yep, that's the plan.
All right, so we will look forward to more conversations if you're interested with Adam about Flip-Chip COB.
All right, thanks, Adam.
All right, thanks, guys. It was awesome. Appreciate it.
Yeah, thank you.